the lecture. Okay, so last time we were talking about the Elmore delay tree. We explained that the way Elmore delay works is by approximating for every capacitor the effective resistor path. And if my main delay that I'm trying to find the time constant for is between two nodes, S and I, and this is the main path, then every capacitor, whether it is on the path or off the path, will be multiplied by the shared resistor path. يعني بحالة C2 the shared resistance is R1، بحالة C1 لأنه هيدا is off my path، بحالة C1 it is also R1. Same for C3 حيكون R1 plus R3 plus C4 R1 plus R3 and so on so forth. So إذا بدي أشوف ال C1 حتنضرب ب R1، إذا بدي أشوف ال C3 حتنضرب ب R1 plus R3 and the same for C4 because C4 R4 is off the main path. Okay, and now we will take this Euler path and Elmore delay path, and we will try to use it to derive the delay of a distributed wire. يعني نحن قلنا أن الواير إذا ما بدنا نعتبره one lumped R and C, if we want to assume that it is small portions، كل portion هو عبارة عن R delta L و C delta L وعندي repetitions all the way of these until I reach my final fulfill the length of the wire. And if I want to divide the wire into n sections ساعتها الدلتا L بتكون بتساوي L على n. Okay. طيب هلا the first step is to assume that I have a distributed wire with R1 C1 R2 C2 Rn Cn between nodes Vn and Vn, and we want to use Elmore delay in order to find the time constant. I'm going to type it here because it is much easier to type the expression. If I want to find the time constant tau, okay, so if I want to calculate tau, it is going to be C1 times R1 plus C2 times الباس. إذا بدي أرسم الفول باس ديلي هو كل هول ريزستور لأن this is the full path delay, and the shared path delay. So if we want to look at the slideshow again a little bit, the full path delay is from Vn ل Vn, and the shared path delay إذا عم طلع مثلا على C2 هو R1 R2. Okay, so if I want to type the resistance for C2, it is going to be R1 plus R2. And if I want to look at C3 the same حيكون R1 plus R2 plus R3. وآخر شيء إذا بدي أروح على Cn حيكون مضروب ب R1 plus R2 plus لعند Rn. Great, so this is the time constant for the overall circuit based on Elmore delay. هلا if my wire مقسم ل equal portions where each one has R1 is equal R2 is equal ل Ri for all I is equal ل L على N ضرب little r where little r is the ohms per unit length. يعني ohm per meter مثلا. وإذا little c كمان ci بيساووا بعضهم بيساووا c ضرب L على N where c is also capacitance per unit length. ساعتها this equation will be c times CI اللي هي C ضرب L على N، يعني C ضرب L sorry let me type it well على N ضرب R ضرب L على N where C and R هن per unit length مضروبين من أول component B1 بتاني component هيدي هي 2R صاروا مضروبين ب2 بتالت component مضروبين ب3 and in the last component they are multiplied by n. Okay, so صار عندي series هون and this series I know how to sum it. Okay, and the summation من 1 plus 2 plus 3 لعند n هي هيدي ال quantity, it is n into n plus 1 over 2. Okay, and this is multiplied by the little resistance Ri اللي هو R ضرب L على N, and this is multiplied by the little capacitance اللي هو C ضرب L على N. هلا now if I want to simplify, this is the time constant for the wire which is divided into n divisions. If I want to look at these expressions, C ضرب L هي ال big C wire لأنه هي ال capacitance per unit length ضرب the full length of the wire. R ضرب L هي ال big R تاعون الواير لأنه resistance per unit length ضرب ال length of the wire. And n بالdenominator هي n squared. Now if I want to evaluate this when n tends to infinity يعني أنا إذا قسمته للواير into very very small components, Mira, I will answer you in a second. Okay, then this is n squared and this is dominated by n squared, and so this will come up to be 1. بيبقى عندي الهاف يعني التايم كونستنت حيطلع بيساوي C wire هيدي N هون سوري مش W حيطلع بيساوي R wire اللي هي little R ضرب L ضرب C wire اللي هي little C per unit length ضرب L divided by 2. So my time constant now is really this expression. Let me read Mira's question and then we will check how this compares to the original thing. This is only the case we do not have of path component. Yes, Mira, when we have the wire and we are dividing the wire into branches, then this wire can be represented by a time constant RW ضرب CW over 2. You are thinking maybe of the net which is splitting where there is some off capacitive path يا أما نصير بدنا نطلع لها الأوف capacitive path حسب اللينكس البرانش تاعونا حسب اللينكس يا أما we treat up to the يعني إذا نحن عنا wire which is branching out this way okay 2 branches يعني يا أما we treat the delay up to this point and then we calculate the delay up to this point and up to this point by analyzing the length of the wire يا أما بصير بدي أعمل a complex derivation like this but we are going to take it by parts. Okay, يعني كل واحد عنده effective time constant and effective delay from point A to point B أو we will try to rederive this by parts يعني نصير بنعمل lumping للcapacitance كله هون أو شيء هيك. Okay, we can talk about that later what approximations we can put. But first let us look at the single wire now which is a stretch. And this single wire which is a stretch, we just found that the time constant هو R wire ضرب C wire over 2. يعني فعلا أنا لما كنت عم بعتبر إنه time constant هو RC I was being pessimistic لأنه هو الإفكت تاعونه is less because not all the resistance is driving all the capacitors of the wire. Some resistor parts are driving only the capacitor after. So from here on, we will now look at Elmore delay to be used to help me therefore to model the delay of the wire model the delay of a series of transistors and model the delay of a pull-up and a pull-down network. يعني إذا جينا اطلعنا على NAND gate مثلا, the pull-down part of the NAND gate looks very much like the ladder of the wire, but the difference is that if this is my out, I know that this transistor is on. I know we will learn how to find R1 and we will learn how to find R2. We already know how to find capacitance here, and we already know how to find the capacitance at the output node يلي حيجي من NMOS, whatever PMOS is also populating the upper P block. Okay, and now if I'm looking at the delay to pull down the output node, I will really invoke an Elmore delay network اللي هي عبارة عن R1, R2, and the capacitors that are here, and my target when is source اللي لإلي. This is the most important thing in defining this. My source node هي الجراوند لأنه أنا I'm pulling things to ground, and my I node تاعت الألمر هي الأوت لأنه أنا I am pulling the output all the way down to follow the source node, which is my ground. Okay, so we can use Elmore to derive the delay for a gate. We can use Elmore to derive the delay for a wire. And what we have just seen is that for a wire of length L, okay, which is modeled by N segments, كل portion عنده resistance هالقد وcapacitance هالقد, with time constant حيطلع بيساوي R wire ضرب C wire. Sorry, but if you can mute yourself if you're not asking a question, or if you cannot hear me, let me know by chat. طيب, so هيدا بيطلع R wire ضرب C wire. هيدي M plus 1 N into M plus 1 over 2. هيدي شالوا ال L على N أو شيء. I think this is the final derivation. Okay, and therefore the time constant is RC over 2. Okay, طيب, so it is still quadratic in L. Okay, because the R هي C ضرب R ضرب L وال C هي C ضرب L, but it is half that value which is predicted by the lumped model. And so what we have on this chart here is we have a table, and the table tells me that if I know the RC of the wire, if I want to assume the lumped model, let me see what Johnny has a question. How do we know the source? So Johnny, if I am in a gate, and I am, sorry, I don't know if this is Zoom going bad or في noise. If I have a gate and I'm trying to pull down things to ground, then the main signal or driver is the ground, the CMOS gates. If I'm trying to pull the output using the PMOS to VDD, then I'm really pulling up to VDD, and the main source is VDD. This is typically. Now later we will learn about pass transistor gates, where we define the input and the transistor becomes like a resistor. هيدولك بنحكي عنهم بعدين. But so far for the CMOS gate, if I have a pull down effect, the source is the ground. If I have a pull up effect, the source is VDD. Okay, so let us erase all of these now, and let us look at what this table is trying to tell us. This table is saying that if you assume a lumped model for the wire, then if I'm looking for the 50% delay and I use the exponential equation, my time constant tau is really 0.69 RC. And if I'm looking for the rise or fall time, it's 2.2 RC. Now, based on simulation, they get those numbers, but for us, we are not going to use those numbers. We are going to use 0.69 over 2 ضرب tau, where tau is equal to RC over 2, and here we will use 2.2 times tau, where tau is RC over 2, okay? Which is 1.1 RC if I'm looking for the rise or fall time, okay? So now they're asking me about an aluminum 1 wire with length 10 centimeter and width 1 micrometer, and we are trying to find the delay across this wire, okay? So if I assume a lump only C model with a source resistance driver of 10 kilo ohm, and that the lump capacitance is 11 picofarads. In this example, he is telling me you have the R driver here with its input signal, which is either ground or VDD. And then he's telling me that I have a lumped capacitor for the wire. So what we do, we have already derived in previous sets of slides that if I know the length and the width, I can find CPP and I can find C fringing for this wire, assuming there is no interwire. I plug the total here and I find the time constant based on the lumped RC لأن عندي 1 C من الواير و 1 R من الدرايفر. So he calculates the total delay as 0.69 times R driver times the capacitance. هيدي بعده عم بحط R driver. Now the second assumption, he also finds that T 10 to 90%, so the rise time, and he calculates it. Now the second assumption, he's asking me to find the distributed RC model, but this time he does not tell me I have an R driver. He is just trying to look for the wire delay, and he is just assuming that it's going to be blocks of R and C, and he wants to find the delay across this wire. This time he gives me little c, which is capacitance per unit length, and little r, which is resistance per unit length, and those values are derived from the tables لأنه أنا بعرف per إذا معي الواير width ومعي ال CPP coefficient بقدر طلع منه ال capacitance per unit length والfringing كمان is per unit length, but he's making things simpler for me. He's saying assume that this is little c per unit length for the wire. And so what we really need to do is we really need to calculate the wire resistance, okay, and the wire capacitance اللي هي ونقسمها على 2 لنطلع time constant ونضربها 0.69. يعني حنجي نقول little c ضرب L هو الواير capacitance مضروب اللي هي هو مقسمها هون وبارت من هاي لأنه هيدي هي L squared, okay? And then we will say this is little عفوا this is little r, and then this is little c, and it's also multiplied by L اللي هي محطوطة هون كمان والL محطوطة هون كمان. So هيدا C R wire, C wire, okay, and the time constant is over 2, and I need to multiply this by 0.69, and I get the 50% delay for the wire on. Okay, so it's simple, it is basic. I really need to find big R, big C divided by 2 and multiply it by 0.69. حدا عنده سؤال so far؟ طب great. هلا we're going to erase this and see what next he is looking for. 90% عم طلع لي إياها من هاي، هو قصده 10 to 90. And then after this he's now saying, well, what if we have a different type of wire and we want to find what is its little c. So عم يشرح لي إنه أنا بطلع little c, okay, from بما إنه الواير width هو 1 مايكرون، إذا اعتبرنا إنه W هي 1 مايكرون، فيني طلع little c من C parallel plate طبعا مضروبة ب 1 مايكرون W plus 2 times ال CF fringing لأنه هي per unit length. Okay. And this has to be multiplied by L نطلع منها البيج سي. والresistance مفروض تكون أنا عطيتكم table للليتل r and you multiply it by L and you can find it. Okay. and the 0.38 جاي من التيبل نحن عم نحطها 0.69 over 2 لأنه هو حينقسموا كلهم على 2. أوكي. طب so بطلع البيج R بطلع البيج C بقسمهم على 2 بضربهم 0.69. The same happens for the if I have aluminum 5 هو طلعهم من التيبلز. أوكي لأنه الويدث تاعونه هو 1 مايكرون هيدي كأنه ضربها ب1 لل CPP and then this is from tables and then this should be the 0.69 over 2 مطلع الديلي. Okay. So this is how we get the delay for a single distributed stretch of wire. هون بس عم نقلكن إنه هيدي CPP وهيدي CF عم ذكركن فيها and this is really what he used here and what he used here. Okay. Now we're completely ignoring the interwire capacitance in this example. طيب great. هلا صرنا نعرف how to handle the wire. He is now deriving for me. Now when I have a gate driving a wire, how do I handle things? So when I have a gate driving a distributed wire, إذا بدنا نجي نطلع عليها كهيدي الجيت R وهي is ignoring now the capacitance of the gate, although I can put it at the end of the gate. But let us assume that it's small compared to the wire capacitance. And then I have my wire, which is little branches of R and C, little r and little c until the distributed gets satisfied. Okay. So ideally speaking نحن already اتفقنا إنه هاي البورشن بالجرين هو عبارة عن RI ضرب CI ضرب 1 plus 2 plus لعند ال N. Okay. What gets added up is really that بدل ما يكون ال C1 إذا هيدي هي C1 بدل ما تكون ال C1 بس مضروبة ب R1 اللي جاية من الواير حتصير مضروبة ب R1 plus R gate أو R driver. أوكي. ونفس الشيء C2 حتصير مضروبة ب R1 plus R2 plus R driver. يعني R driver لأن هي موجودة على الفول باث اللي رايح من الانبوت للأوتبوت all the capacitors will see it. So in the end I will end up with a term which really is whatever we derived before plus R driver مضروب بكل الكاباسيتورز يعني مضروب بجمعهم يعني مضروب بالسي واير. اوكي. So the time constant من الواير حيضل هو ذاته R واير ضرب C واير over 2 but I will get an additional term اللي هو R driver ضرب C واير. Okay. And now my total delay will be 0.69 plus ضرب هاي معلش هاي حننساها بس for consistency لأنه هيدي more accurate by simulation بس for you to be comfortable RW ضرب CW على 2. Okay. So now I can see that the two components الواير والدرايفر لو هي ما عندها كتير capacitance they are competing for the delay and contributing to the delay. Therefore بدنا نشوف أيمتى بصير الانتركونكت واير is critical. نحن بنعرف إنه RW ضرب L هي RW و CW ضرب L هي CW الكبيرة. Therefore I can know at what length from this relation هيدا ال component is dominant أو هيدا ال component is dominant أو أي أكبر. So we just say well the wire delay is dominant لما RW ضرب CW على 2 كتير أكبر من R driver ضرب CW ضرب CW. Okay, CW and CW cancel from both sides. بيصفي عندي ال R driver. We're comparing it to RW اللي هي little RW ضرب length of the gate, length of the wire عفوا. اوكي سو بصير في عندنا relation بين L و R driver وال resistance per unit length of the wire. Okay. And if we plug in those information and we know this, the width of the wire and its resistance per unit length, فينا نطلع إذا بنعرف little RW ومع الgate information مع ال R driver, I can know from the ratio what is the critical length. So بالألومنيوم 1 مثلا if the net is greater than 2.67 بصير ال interconnect resistance wire delay أكبر من الgate delay وكمان it is appreciable at even smaller length. اوكي حدا عنده سؤال على هيدي السلايد؟ طيب great. So it's a pure linear relationships which we are trying to handle here. So now he starts to give me rules of thumbs إنه إذا أنا بدي أطلع إمتى I consider the RC delay of the wire. If somebody tells me that this is the gate delay لأنه باللايبراريز عادة ما بقول R driver بقول تقريبا الانترنسك gate delay هو هالقد نانو seconds. بقوم بجي I compare it to 0.69 ضرب RC over 2 and I try from this بما انه هيدي proportional ل L squared to هيدي بتبقى عندي هون 0.69 R little RC over 2 بيطلع عندي relation بين L squared والديلي للجيت والليتل RC. Okay, so this is another way of looking at things by just saying that this is RL هون وهيدي هي C ضرب little c ضرب L وبحط L squared بشوف ال L critical بالنسبة لل average gate delay. طيب great. And then he is telling me that if the signal which is arriving to the wire إذا أنا عندي wire وجايته signal من هون إذا هيدي is very slow, the rise time of the signal is very slow, then we do not consider the wire as distributed لأنه مش محرزين نعتبره lumped. But if the signal rise is very fast يعني إذا طالعة steep, then I need to consider it as distributed لأنه بيأثر علي وهي لأنه بيدخل other nonlinearities or other complexities in the equation. But these are just rules of thumb. We will worry only about the upper part here اللي عم يحكي عن ال wire delay versus gate delay. Okay, طيب I'm going to stop here. Okay, and I want you all to switch now to Moodle. I will stop recording as well. Okay.